Hello, discrete math fans. Let's write out the complete list of 3 combinations with repetition allowed from the set 1, 2, 3, 4. Now we're going to write all the elements in the multisets in increasing order just to help us not miss any. Well, here's the list. This is the complete list of all 3 combinations with repetition allowed, also known as multisets. Keep in mind that with multisets, we're allowed to pick the elements more than once. So there are 23 combinations with repetition allowed. But how do we know that there are 20 without going about the trouble of making a complete list? And even though we've set down to write a complete list, how can we be sure that this really is a complete list? Maybe we missed someone. All right, let's make a table to categorize some of these multisets. Okay, so the multiset 1, 3, 3, I'll just put a star in category 1 and a couple of stars in category 3. The multiset 1, 2, 4, I'll just put 1 star in category 1, 2, and 4. What about the multiset 2, 2, 2? I'll just throw down 3 stars in category 2. So each selection of 3 numbers from the 4 categories can be represented with a string of vertical bars and stars. So, for instance, when we took 1 from category 1 and 2 from category 3, we can represent it like this. The bars are separating the stars. So what you see is, here's category 1. Category 2 has nothing. There's 3 things in category 2, and category 4 has nothing. So each different multiset of 3 elements taken from the set 1, 2, 3, 4 can be formed with the different arrangements of 3 bars and 3 stars. There are 3 stars because we're selecting 3 elements. There are 3 bars because we have 4 categories and we just need 3 bars to segregate the 4 categories. So the number of distinct selections of 3 stars that can be formed from the set 1, 2, 3, 4 with repetition allowed is the same as the number of ways that 3 bars and 3 stars can be arranged. So we count this by placing 3 stars into any of 6 positions. So we're just counting a 3 combination from a set of 6 elements. Now it's a combination because when we place the 3 stars down, we don't care what order the stars go into. So we can count this by doing 6 choose 3, which is 6 factorial over 3 factorial, 3 factorial. All right, so as a general theorem, we can say that we have a theorem, which we'll call the method of stars and bars, which says that the number of R combinations with repetition allowed, or we can call them multisets of size R, that can be selected from a set of n elements is R plus n minus 1 choose R. We're going to remember this by thinking of how many ways there are to permute R stars and n minus 1 bars. The R stars correspond to the number of things that we're selecting. The n minus 1 bars correspond to partitioning the n categories. Okay, that's all for now.